Our idea is to minimize the cost and delay of the rescue operation. Components required to build this robot are less, and maintenance of the robot is also economically cheaper, and it is cost effective. The time it takes to complete the mission under any circumstances is also less, thereby minimizing the delay in the rescue operation. It is an user-friendly robot as it is operated using an Android application. The robot, consisting of CCTV, oxygen supplier, will be sent into the borewell, which makes the rescue operation more efficient and accurate. With the supply of oxygen inside the borewell, victim can sustain for a longer time and hence increasing the chances of saving victim's life.
And this is a prototype model of our project. Our arm mechanism, which is mainly consists of the 4 servo motors, the upper 2 servo motors and lower 2 servo motors. The upper 2 servo motors will be tilted at 45 degree, and the lower 2 servo motors can be tilted at 90 degree. And and the lower 2 servo motors, which is mainly used for gripping purpose, for picking the victim which is fallen in the borewell. This is a camera which is visualizing the victims which is falling in the borewell. And
guys, I am Deepak Kirangi from Karnataka. Here I am going to explain you about the circuit part of the robot. It is mainly consists of the Arduino Nano, the brain of the robot, and it is consists of the L293D IC, which is used to control the DC motors, and 7805 regulator, which is used to convert the 12 volt DC supply into the 5 volt DC supply, which can be used to power out our servo motors. And it is consists of the PWM pins, and it is consists of 6 PWM pins, and among us we can use 4 PWM pins for controlling the servo motors, and the 2 digital pins for controlling the DC motors. And here is the what we showing is the Bluetooth module, which is used to wireless communication between the Android device and our rescue robot. And this is whole circuit part which is done by us.
Hello everyone, I am Sangesh K. Kradhan. To program the microcontroller, we have chosen the Arduino IDE platform, and we are writing the programs using embedded C. When your program starts execution, first the setup function is invoked, and it is invoked only once during the execution of your program. And the loop function is repeatedly invoked until the user decides to terminate the program. In the loop function, we have invoked 2 more functions, servo function and the DCM function. The servo function is used to run the servo motors, and DCM function is used to run the DC motors. Program takes the values sent by the Android Bluetooth as the input, and depending on the input value, it chooses one among the 2 functions of the loop function, and it is calculated value is sent to the Bluetooth module connected to the Arduino. The result can be viewed on the serial monitor of the Arduino IDE, and this is the Android application built to control the robot. These 4 buttons are used to control the servo motors, and these 4 buttons are used to control the DC motors, and this app is called as D-Arms. When you touch the slider button, the result is seen on the serial monitor. You can see on the screen here. For reality, we have chosen our prototype to implement in real time. Assume that this is the victim which has fallen into the borewell. In our case, it is doll. And this is the overall arrangement of our rescue robot system, the pulley arrangement. You can see that the bot is hanged to the pulley, and this is the circuit of our robot mounted on the robot only. This is the webcam or camera which is used to visualize the victim. And this is the pulley. We have connected a DC motor of 30 RPM in order to provide the vertical motion of the robot in the borewell. Now we are ready to send our robot into the borewell, and the robot is being sent to the camera. In first slide, you can see the using external camera we shot that the borewell is the robot is sending into the borewell, and in this slide you can see that the bot is sent to into the borewell, and this is shot through the camera that is attached to the robot. You can see the internal part of the robot. The bot is about to reach the doll. The grippers are now ready to pick the doll. Using the DC motor, we are rotating our robot in order to adjust the position of the robot in such a way as that we can adjust our grippers to hold the doll, and the grippers are holding the doll now. And they have successfully picked the doll, and it is coming up now, from the borewell.
first slide is shot using an external camera, and second slide is shot using the camera that is attached to the robot. And we successfully uplifted the baby which has fallen in the borewell.
Hi everyone, I am Rakesh. The main challenge was to design the robot which would fit into the small dimension of the borewell, which is at maximum 8 inches, and also to mount circuit and camera on the robot. The controlling of movement of the arms of the robot in the borewell was also quite difficult, as there were chances of arm touching the walls of the borewell and cause mud to fall on the child which has fallen in the borewell, which is threat to life of the child fallen in the borewell. In our earlier proposal, we have specified oxygen supply, but due to unavailability of oxygen supply in our region, we could not include this feature in this prototype. Except this feature, our robot is completely ready for real-time implementation, and we have shown the real-time implementation of this prototype in the demonstration section.
The total expenditure of our prototype around 6,000 rupees, and 2,000 rupees for motors, and 1,800 for camera, and 1,300 for components of circuit board, and 700 for other robotics components.
There are chances of the child falling into the uncovered borewell. The existing methodology is to dig a big hole beside the borewell, which requires a large amount of human resources as well as machineries, and it is the time consuming and the probability of successful operation is less. But our design is such a way that directly enters into the borewell and picks the child more safely outside, and there is chances of the saving of the child is also more.
The implemented prototype is almost same as our proposed prototype. Our robot is Bluetooth controlled with the Android device. As nowadays almost everyone has the Android device, any user with the minimum knowledge of the functioning of this robot can operate this using the Android app we have designed. The size of the robot is 6.5 inches, which is capable of moving inside the borewell, and arms are provided with a more flexible movement without touching the walls of the borewell. The time it takes to complete the mission under any circumstances is also less, and it is cost effective as it requires less components to design, and chances of saving victim's life is more.